Once you find your place is really, really good.
Yeah.
Luckily, there's no other aerospace engineers here to say we're wrong about the orbital determination stuff.
Maybe they'll tell
We
us.
can talk out of our butt cheeks and stuff. We'll be fine.
Like one person on your team can connect to the projector and present slides, and then everybody else can just present normally. Thank you to our judges for being here and our sponsored bots. I'll let the judges briefly introduce themselves, and then we'll get started. Thank you.
Start your.
Hi, I'm Williamson. Most of you probably already know me. I'm currently drinking a bunch of caffeine. Next.
I'm Eli, software engineer at Northrop. It's nice to meet y'all.
I'm Justin Olson, team and project lead and software engineer at SAIC. Started this thing way back when, the Computer Science Club in ACM around 2016. Eli is also a former president, if any of you remember that. Thanks for having us.
Y'all tell us when to start. Or we just go?
You're good.
Okay, perfect. So our team name is Lucky Feathers of Toronto. We don't know how it's pronounced. It's the lemon team, and we chose to do the bot sensing challenge. If you could do the next slide, Brody. So we're gonna quickly introduce ourselves. I'm Maris. I'm a senior aerospace engineering major here at UAH.
My name is Graham. I'm a freshman mechanical engineering major here at UAH.
I'm Sam. I'm a senior aerospace engineer.
I'm Brody. I'm a senior aerospace engineer as well.
So we chose to do the bot sensing solution challenge because it aligns with the key topics in our field, mainly the sensor for the Spot-6 satellite, which is very related to orbital mechanics, and the sensor for the Predator UAV, which is very related to flight dynamics. So our biggest problem and our biggest challenge through our careers and through this challenge is that classic 2D visualization just doesn't make the cut when we're trying to visualize all of these complex things, right? With the aircraft, you're trying to do like Euler angle transformations. You're trying to get like different references in the body frame to like your inertial frame. It's just very confusing to try to visualize it whenever you're solving problems. Same thing with orbital determination and orbital mechanics. You can kind of get a sense of what they're talking about whenever they're deriving all of these variables, but once you do problems, you have no clue what's really happening, what's stuff where related to what. So here we have a couple of examples. We can go through the next slide. So with the Spot satellite, our main issue is going to be how can we analyze the ground track of the satellite, and how can we connect this bridge between the theoretical math and engineering concepts to this real world data, which is in like discrete time steps. So our implementation is going to be, we're going to request the data from the Spot-6 API. We're going to calculate our orbital parameters. We're going to do our orbit determination, and we're going to do orbital predictions as well, and then we're going to visualize them in 3D space. That's very, very simple. It's not going to be technical at all, but it's meant to be like innate whenever you're doing your homework. You can visualize it and clearly tell where things are, even if they're not necessarily up to scale, right? Next slide. So the next one for the Predator UAV, we wanted to analyze the flight dynamics, especially those rotations in 3D space that are usually very hard to like imagine and visualize in your head. And then we're going to do also some mathematical analysis and presentation of the control surfaces. And our implementation is going to be request the data from the UAV API. We're going to organize our yaw pitch in a roll, and we're going to animate the UAV with the previous data that we just got.
Okay, so a quick mathematical background on what went into our program. With the data from the API on the UAV, we were able to directly plot the orientation of the vehicle. So then our next question is, what could be happening with the control surfaces? So we focused in on the rudder control dynamics in this example. And so just for the sake of time, I only had access to the derivatives for a Boeing 747 aircraft. So our UAV is now a Boeing 747 for this example. But we were able to back out the rudder dynamics and calculate potential rudder deflection with the API data. Next slide. And so then we also looked at the Spot-6 satellite, and what we noticed is we were given the position and velocity of the Spot-6 satellite. So we can calculate our 6 orbital parameters, And with 6 orbital parameters, you now have the full elliptical orbit of your satellite. So now, with the 6 orbital parameters, you can calculate the rotation matrix in order to take your ellipse and then rotate your ellipse with respect to a geocentric frame or an Earth frame. And so that's what we were able to do in our code.
Okay, now putting all of the things that Sam said into code. So here we test our harness data to get our rudder deflection angle. So we have we ran the code from the UAV to get the UAV API to get some elapsed data, and we put that into Sam's code, and we get at the very top you can see that 2.525. That's going to be our rudder deflection angle, and so that's kind of a little bit of the surface analysis we do. And Bert, if you want to go to the next slide, we can show the orbital predictions. So one of our analyses for the satellite is if we're given these initial parameters, the position and the velocity, and we figure out the period based on some kind of orbital parameters given the orbital dynamics and the flight path, we'll be able to predict the orbital path as we see here. So in this very first image, that is the initial position of the satellite, given our center reference frame being Earth. And obviously you can see this elliptical orbit path. After 1 hour, we see we'll be able to predict where the satellite is. And then after 2 hours, we'll also be able to predict where the satellite is here, given our analysis of the flight path, the orbital path.
Okay, so now I'm gonna run through our demonstration. I'm gonna show you a little bit about our app. So right here is our main page. Right here is just our logo, and then these two right here is a button that'll take you to the UAV. This is a button that'll take us to the satellite. So we'll click right here. And this takes us directly to a nice visualization of the yaw, pitch, and roll for just a quick snippet of some of the historical data, or not, the live data from the UAV sensor. So you can see the yaws changing. Just from like the small, quick snippet, there is no real change in pitch and roll, but we were able to see some change in pitch and roll, which is hard to actually capture that. And then we will go over to the satellite plots. Here we have an actual image of the Earth and also our elliptical orbit. And you could visualize and spin it around in 3D space to see where your satellite actually is with respect to the Earth. We'll go back.
Do force finger swipe up whenever you go to the left. Like this.
I don't know how this works. Okay. So there were a couple of shortcomings with building this app. Obviously, none of us are actual programmers, so a lot of the challenge for us was building the GUI and actually trying to visualize the data. So a lot about what Graham talked about earlier, we weren't really easily able to visualize onto our GUI given the time. But I think we learned a lot of lessons, such as integrating multiple scripts requires a lot of careful planning. We didn't really think that much far ahead, and I think if we had thought more ahead of time, we could have very easily implemented some of these things. Creating a block diagram early on in the process could have really helped us visualize how we wanted our program to flow, and it was something that we kind of just scrambled to do. Same with completing some of the simple tasks first really could have made it easier for us to just implement everything in at the end and not have to scramble right at the end of these past 6 hours. And then, lessons learned, visualization really is the key to learning, especially in our field where there are so many different variables, there's so many different things going on in a 3D space, and it's really hard to try to visualize that 2D in your mind. So we really think that this was something that would be helpful to aerospace engineers, mechanical engineers, or anybody who wants to learn about orbits.
I'd like to add on to what Brady just said, and to you judges thinking about the kind of validity of the visualization of our project. I'm a freshman mechanical engineering major, and I didn't know orbital dynamics, flight path, and when you're out the when I got into the hackathon, but I was able to learn through visualization, through this coding, I was able to learn what yaw, pitch, and roll actually means, how it relates to the aircraft, and visualizing that through our project actually helped me learn something new as well, so it does work.
Again, like Brody said, I think our biggest shortcoming was realizing how much harder it is to actually build the app. We have all of our functions that give us all the data we want in real time and all this stuff, but somehow figuring out a text block to relate to that function took us hours to do, and implementing kept us giving us errors. So definitely planning the structure of our applications in the future is, I think, the biggest takeaway from the hackathon.
Yeah, if I could add on, GitHub and Python were both new to me, and GitHub definitely caused me more issues than Python. Yeah, it's a powerful tool, I can see that, but for a day-and-a-half project, group project like this, it is very beneficial to already have that on-ramp. But yeah.
Very fun. And fellas, if y'all have any questions, anyone?
I have a few, yeah. A comment first. Maintain better GitHub practices to avoid merge conflicts. Lots of people on my team where I work need to do better jobs of that. So everybody in this room, the earlier you can learn the importance of that and get good with Git, do that, because that's huge.
They're doing it right now.
Yeah.
Most of them are.
That's an important lesson that you guys learned. Where did the API data come from Open Sensor Hub?
Yes, it was presented, or we had the access to the data in the challenge sheet. So we could just, they had this website where we could scroll through the sensors. It was also our first time, none of us had ever used an API before.
Right.
So we had to learn how to use the API, but we chose the 2 sensors, and then they had like the data streams that they had for each one. And so knowing what we wanted to do and how we wanted to visualize it is the data that we pulled from those sensors.
I gotcha. What did your tech stack look like? Like what technologies did you guys use aside from Python?
So most of it was built in Python. We used a bunch of, like, for example, to pull from the APIs, we used like the Python request library, and we used a bunch of like different Python modules. All of our graphing was made by ourselves. So we did all of the math, and given the 3D points, then we grabbed these object files online for free. And with the mesh of the object file, we would apply the transformation to every single vector in or every single vertex in the mesh, and that's how we did all of our plotting. So that's, I think, why we had so many issues with the integration into the applet with the GUI, because they weren't just figures, but it was like this big collection of like the meshes and stuff, and it just kept crashing all the time. So we couldn't get it in like real live data because of that. But everything was done mostly in Python.
Yeah, to build the GUI, we use PyQt5.
Okay, I was just about to ask if you guys do Qt at all. And you would say that if you could do it again, you would have spent a little bit more time planning up front?
I would have tried to set up the GUI a little bit better so that it would have been easier to drag and drop things in, because we had like a lot of parts, like just in the past few hours, we wanted to add some of our graphs, and it takes a lot of time to start actually putting that onto PyQt5. So if I had more of a framework set up, I think it could have been really easy for us to maybe change our minds about what we wanted to show based on like what we found out as the process went on.
I gotcha. And did you guys, you said little programming experience. What kind of programming experience did each of you have?
I've done a little bit of web development and then just general programming experience. Like we do numerical methods in our engineering courses, so just a lot of mathematical functions and like calculating derivatives and doing numerical
Now, is that with
integration.
MATLAB or is that with?
Yeah, we do MATLAB a little bit and then also a good bit of Python.
Okay.
Yeah, I have pretty much the same background as him. It's mostly like for our engineering courses, MATLAB, Python, how can we apply the math to it? And then I also use, like I code for computational fluid dynamics, but that's also very in the same vein of like numerical methods. How do I apply this math into the actual points that we have?
And you're a freshman.
Correct.
So is this your first experience with coding at all?
No, well, we have an engineering 101 course where we take a Python and MATLAB class.
Okay.
I haven't done much like kind of visualization coding, but I've done a lot more like analysis coding in the past, so I have a little bit of experience, but not much in something like this.
What about you?
Yeah, I got like a 3-month intro into Python, but then all of my experience has been within MATLAB. Had like a modeling and simulation controls internship for a while, and so that was really heavy into MATLAB.
Right.
So very familiar with MATLAB, not so much with Python. I've done some stuff in like the Arduino IDE, but that's pretty much it.
My last question is, do you all feel like you've learned stuff that's going to be helpful moving on in both your academic and professional careers?
Absolutely, yeah.
So much.
Yeah,
Good.
I had a compressible aerodynamics teacher that asked everybody what's their preference between Python and MATLAB, and then he proceeded to go on his big rant about how MATLAB, we need to get off of our MATLAB because MATLAB is not free. Python is.
Right, yeah. You'll run into those constraints in the real world sometimes too, so,
It's also a slow black box.
yeah.
You have anything? I have no questions. Yeah, we're good.
I think you guys did a good job, thank you.
Thank you.
I'm always impressed by when somebody comes up with anything. Oh, if anyone ever tries to read my work notes,
It's bad.
yeah. Some of my like list of things to do this year is to get prepared. Yeah.
Oh, right, forgot our team lead. Okay. Ready? Okay, so I'm Sam Whitlock, that's Josie Whitlock, and we made Astro Tracker. So first of all, here's our team structure. Of course, we had to put the strongest programmer at the top, so that's my stuffed animal named George. And real talk, we had two people. We didn't want to put one person above the other because we were working sort of in tandem. So we put George in as our place-in, our stand-in lead. Okay. So first, our team lead. This is George. And yes, I did not misspell his name. His name is George with a J. The J is in the position of the first and the second to last character. So it collapses down to a single place whenever you start writing his name. Anyway, yeah, he doesn't have much experience, and he's an axolotl. Anyway.
Hi, I'm Josie. This is my first hackathon. I'm a sophomore studying computer science, and I've done a few coding competitions before, but not a hackathon. This is my first.
And I am Sam. I am a freshman. I have done one coding thing before, coding competition, which was the hackathon hosted by the Charter Hack last semester. And yeah, that along with 18 years of nerddom and being a computer science engineer is my experience. Not computer science major. There we go. Okay, so we picked the SW prompt because we thought that there was a big hole in the market that we'd seen before, big hole in the area that we thought we could fill pretty easily based on the estranase. So Josie has used estranase before. What it is just a tool to calculate the amount of estrogen in the body, specifically for hormone replacement therapy for trans girls and trans women. And so we know that there's not much on the Google Play Store or anything else like that. So there wasn't much of another option for people that needed something like this.
Our project, there's a bunch of different estradiol esters that it takes and it collects over time. So estranase, the tool that we had beforehand, that one, it does not work over time. It does, but it doesn't keep track of things for you. So we wanted one that would do that for us, so we could just consult it and see what levels are at any given time. So that's what our project does. It has some magic numbers, but it's pharmacokinetics information that we took from a couple studies that takes a list of doses that have been taken by the user, and at any given day in that time frame, it will give you your estrogen level in picograms per milliliter.
Okay, so I get to say a special thing on this slide, even though it's not really my slide. Vico, that's a graphing software that we use. The documentation is terrible. Like this weekend, we learned why you need to have good documentation. So I spent a good 4 hours yesterday straight just sitting there trying to figure it out.
Yeah, we used Vico, which is our charting library for Android Studio with both Jetpack Compose and Views, but we used Jetpack Compose, which is a framework in Kotlin and Android, and Kotlin's built on top of Java. And we use that to chart the estrogen levels, as you'll see in the demo. And we used SQL and a NoSQL or a SQLite database run in the background through Android Studio's Room database. and that keeps track of doses, and then that goes through a library that I wrote in Kotlin that will go and feed it in all the information and tell it which times it wants information at. That's it.
Okay, I actually forgot to bring my tablet up here, but we do have a working demo running on our tablets and phones, and so I can come up and share this to you in a moment, but this is our demo. We have multiple different pages. We've got a calculator, or a calendar first. That'll show you when you have your doses, when you're due, and what you've done. So according to this, I've missed a dose today. Anyway, then we have a calculator that will convert from the concentration that you have inside your medicine to the amount that you need to take. And if you would like to take a look at it.
And Sam,
Oh, and of course we have it there too.
it's building, but it's
Yes, this is emulator that's still loading at the moment.
it has version. It just needs the latest version.
Should automatically update and stuff like that.
Based on
has
the
a-
calculator.
Yep. Yeah, it calculates
What parameters
from
is it using?
concentration of whatever you're injecting. So in, I believe it's milligrams per milliliter.
Milligrams per milliliter. It has it on there. Actually, the specific units, and it'll automatically update down here.
There we go.
And so it'll tell you how much you need in each area.
Oh, that's not the right.
What about
project.
factors like half-lives in your body?
Those are
That's
calculated.
the magic numbers,
Okay.
quote unquote. That come
Magic
from it.
numbers, are they hard-coded?
Yes, because they're they have to be. They're constants.
They're constants.
They-
They're
they-
constants, but they may be different per
Yes,
by size
they're-
of
they
each
don't.
person.
Yes,
This
so they're
is
not.
also relevant to other chemicals. It's not just estrogen. Any chemical in your body is going to have
Yes.
a varying half-life based on your own chemistry. I'm
Mhm.
wondering if this could be scaled up, not just estrogen, but
It
like
could
all
be.
chemicals. I'd
But
like
this
to know
one-
how much caffeine's in my body at any
Yeah.
one
That'd be
time, right?
That would be cool, but this one is just for estrogen because it's going to vary for each chemical, and also this is more of a guide for where you are with how much it is in your body relative to your peaks and your lows.
And of course, we could scale it up fairly easily, I'd say.
Mhm.
But at the moment, we only have the constants that we have, which are just for the average person
Mhm.
for stuff like estrogen.
They're taken from averages.
From studies.
Yeah. If I can find it. There we go. Yeah, there we go. So we have a log creation. You put in the number of milligrams that you've taken, what day you took them on. So if I take them tomorrow, then it should update at some point. Oh no, this is, Sam still has the old data.
Oh, yeah?
Yeah.
Welcome to tech presentation.
Yeah. It's currently, we had some issues with when the time data was. So this
Oh,
is,
yes.
it probably stretches way far into the future, but it's currently at the epoch 1970
Yeah, it records it
in January. So,
milliseconds, and so we had to calculate the actual current date from that, and so.
and this still has the old data from before we fixed that. But Sam's tablet demonstration should have the current stuff because that's what we were testing it on.
You go ahead and it should update automatically.
Hopefully. Oh, and then we have a way to change the name up there because just welcome name is kind of, unless it crashes.
There's also a dark mode that is not completely finished. There are a couple of screens that don't quite support it yet.
Oh, there we go.
But the main page does, along with a couple of.
The emulator's slow. There we go. Now it says welcome Sam at the top. Yeah, hold on. There we go. No, calm down. It's upset that it's going from the epoch to today.
It happens.
Yeah,
Yeah, it's got, how much data do you
50 years.
50 years.
Most of it's nothing, but
Could be close to 1 million data points.
something like that.
3.5 days.
Mm-hmm.
So yeah,
So,
good. Any other questions?
What if you had more time? what's some other stuff that you guys would have liked to have implemented? Or was
One
there
of the-
anything that you tried, but, you know, time started creeping up on you and you had to
Yeah.
scrap? Was there anything like that?
So we have the calculator page. I don't know if it's, or not calculator, calendar page. I don't know if it's going to come up on here because it keeps freezing. But on there, it should be in there. The calendar page, we have a mock-up. It's not functional yet. It looks weird on dark mode. It's one of the pages that's not.
Weird on dark mode.
Eli.
But it'll color code different days based on missed doses, taken doses, and future scheduled doses.
And then the blue border is where your current day is.
Yeah.
And there are a few things that don't quite work in its entirety yet, but that's something that we would have definitely expanded on.
The other thing is that we have a different way, we have bar charts built in as well. And we wanted to use those so that you could take blood work data that you've gotten done, so you could add in where you are at a certain day compared to your doses.
I see.
And that'll give you a better idea of how your body is handling the estrogen compared to what the reference is. Because it won't be the same for every person.
What were some of the challenges that you guys encountered? with this?
Like the Lemon team, we had a lot of stuff with UI and text and especially the graph not behaving or reflecting what we thought it would. There was a lot of, Kotlin can be kind of weird sometimes with how it handles things. I don't know, Sam, do you have any?
No, it's mainly the largest thing that comes to mind, springs to mind immediately, is just the no documentation for the graphing software we use.
Yeah, that took a good chunk of time, but we also could have planned out some of the, how we wanted some of these features to work as opposed to just trying to wing it,
Yeah.
kind of.
So a little bit more planning on the front
Yeah.
end, documentation struggles.
Mm-hmm.
I'll make a comment on that for everybody in the room. Get used to it.
Yep.
It doesn't get easier. Some stuff is better documented than others, but the more experience you get in there with it, the easier it'll be. But it's always going to be a challenge.
Mm-hmm.
To my
Sure.
senior project students, told you so.
Like I've been doing this for almost 10 years now. I lead people on a team and everything like that. And even I get into documentation and go, what the hell are they trying to say? This is not like that at all. And so yeah, this you're going to run into that all the time. So you guys will definitely be able to apply some of the things you've learned here moving forward for sure.
Yep.
I think that's all I got.
Was there anything that you thought was going to be difficult but ended up actually going really smoothly?
One of the big things was I figured that the numbers with the formulas for determining the relative or the reference level of estrogen would be a lot more complicated to get set up, but it was relatively simple. So
That's the only one I had.
I think you guys did a good job. Yeah.
thank you.
Good job.
Always documentation and planning. We'll have stuff in the documentation. Find a bug in the aircraft. Instead of fixing the bug in the aircraft, they just update the documentation around the bug and stuff like that. So
Yeah.
it's interesting.
I know. It was connected literally
Yeah,
half a
as
second
best you
ago.
can.
So it's probably because I shut my laptop. We'll just start it. The demo. We're good.
Hi everybody, we are Bike Club. It's like Fight Club. And our project, this is a longer name than I thought we were gonna have, is Multivariate Time Series Analysis for Weather Event Prediction. So I guess I'll start since I just talked. I'm Will Humphrey. I'm a senior computer science student, and this is my second hackathon.
Hi, I'm Sarah Ibsen. I'm also a senior computer science student, and this is my first hackathon.
I'm Austin Fon. I am a graduated computer science student in our school, but this is my second hackathon.
I'm Bailey. I'm a CS student, senior, first hackathon.
Okay, so the challenge that we decided to choose was the bot sensing solutions. And our solution was to take the data given from the API and essentially find a average with hurricane data, tornado, normal data, and be able to predict based off of real-time data collection what kind of event is happening.
So for the project, we used a Raspberry Pi 5 as well as a SenseHat module to collect kind of current environmental data based on where you are and get those weather readings and then compare those to our model. So for building it, it started out with a lot of research, especially with atmospheric science. We called 3 different atmospheric scientists that we knew to try to get some information about that. And then it was cleaning up our data to make it consistent, and then researching the different libraries and technologies that we would have to use within Python to create this. Then we would process the data, and we trained a random forest model to help us try to predict those. And then beyond that, we had simulated data, real-time data, and historical data from the bot's API. And then we had to take our SenseHat and the Raspberry Pi and combine the real-time sensor data with our collected data. And then we have an 8x8 LED display that displays anything from, you know, hey, there's a tornado coming at you, seek shelter.
Okay. Let me get back into the little thingy.
I think you mistyped your password.
I know, I did.
So have you guys taken your senior design courses yet?
Bailey and I are in the same senior design.
And I took mine last semester.
Have you guys gotten used to awkwardly standing in front of the projector screen waiting for stuff to happen while everyone's looking at you?
No, I'll never get used to it.
I didn't have that luxury, I'll call it, as mine last semester was online.
Oh, lucky you.
Not lucky me, but I would much rather
I think
have
that is lucky you, actually.
Well, you all get it in equal amounts eventually, once you guys are out there.
We'll just do it here.
I would always research awkward dad jokes ahead of time, so yeah.
First one off the top of your head.
How did dinosaurs pay for things?
How do they pay for things?
They wrote Tyrannosaurus checks.
Okay.
That's pretty good.
Honestly, yeah, that's honestly good.
That's a good one.
Yeah, you have my permission to use it.
I will steal it.
So here,
do you
want me to? I can. Okay. So here's our simulator for getting data because like the sensor is gonna get what's around it, and to test this, we wanted to test it with different weather events, and there's not currently a tornado outside. Well, maybe, I don't know, the wind's down. So we do this to have it create data for us so we can have tornado events, we can have it simulate data that doesn't have any kind of weather event, rain, hurricane. We can do it again with another tornado, hurricane. And so that is gonna make it go into a CSV file. And from that CSV file, we take it and do the model prediction on it to do the, yeah, you can grab that, yeah.
You want me to hit it?
Not yet.
Okay.
Yeah, that's why I get a little fan. Okay, now hit down. And I don't know how well you can see. Tornado is the most likely outcome because we clicked tornado 10 times.
So that's actually injecting that data when you click the button?
Yes, yes.
Okay. And that data is coming from where?
So the simulated data, we just took kind of an average of what so we're getting wind speed, temperature, pressure, and then we have like the date and the time. So we get all of that and we have an average for events, kind of what that looks like.
And that's coming from OSH?
The simulated data, no. The current data that it's being compared to for the model to.
So the way that I trained the model was I grabbed the bot's API data. And I trained it using the hurricane as well as the simulated weather data, because I'm assuming the weather data simulated was normal.
Right.
A lot of this data that we got wasn't categorized, so I had to do a lot of figuring out if this wind means that we had a hurricane or a tornado or
Right.
whatnot.
Okay.
Hence why we called 3 different atmospheric scientists, because
Yeah.
it's hard to compare just that kind of data, like just
When you
temperature.
Don't know
wind
what you're
speed.
looking at, what the
Yeah.
patterns are, and you're not a
Right.
meteorologist.
Because there is so much more that goes into detecting tornadoes, and you need to be able to see radar data and see, is there debris flying, are we seeing a hook?
Right.
I learned more about atmospheric science in the last couple of days than I thought I would.
So is it safe to say that one of the main challenges wasn't capturing the data, it was interpretation of it?
Absolutely.
Yeah, yes.
100%. That was one of the main questions that I asked was, hey, is there a way to compare this limited data to try to produce, because our initial idea was to create some kind of similarity score, and we found that taking a single snapshot of data and like comparing that was not going to give us any kind of reliable output.
Right.
Do you want to show the real-time data too, instead of just simulated?
Yeah.
Okay.
Can we click it?
Yeah, so push
Away from me.
towards you. Yep, since you're holding it. Yep. Okay, and then you can push it away from you now. Cool. And then same thing. Wow.
And is everything being done locally on the Pi?
Yes.
Yes.
Okay.
A lot of the data analysis portion was kind of pre-processing to be able to have it to where it could be on a portable device such as a Raspberry Pi.
Yes.
Right.
Is it in display? Nope, it's an app.
Yeah.
Yeah. I'm just changing the file name because we have separate file for data that we do for the simulated data.
And how did you guys choose Python?
Well, part of that is I know that from some of the atmospheric scientists or students here that were at UAH that I talked to, I know that they use a lot of Python. My partner is a biologist and they use a lot of RStudio as well as Python for data analysis. And that's what we found is there's a lot of libraries for creating graphs out of time series information. The pandas library in Python is really good for manipulating data and CSV files. So that was part of what we learned is like, because what I plan to do is not data science, it is more like front-end web development and stuff like that. So learning this kind of data science portion is the biggest thing that I took away is like what you have to do to be able to do something like this.
Right.
You want to click it? I don't think it's working.
Yeah. It worked this morning. So I don't know. I think that's it.
I believe that's it. Any questions?
The atmospheric scientists that you're citing, are their names known? Will we know who they are if you told us? Like, where do they work?
One of mine is a friend I know from high school. He just graduated from the Air Force Academy. He's a meteorologist for the Air Force.
Very well.
And then the 2 that I talked to are students here that are also in their senior year. One of them is a storm chaser and has done, stuff like that. But I just know them from here at UAH. And so I figured it's probably easiest to talk to somebody who has learned it and knows what they're talking about. That is easy for me to talk to, I feel.
How much time did you guys spend planning before you put your hands on keyboards at all?
I would say we spent a decent portion of that first night. Are you able to pull up? We did make kind of a block diagram for how we envisioned that it would be working. It should be.
Is it just?
It should be in the Discord.
In the Discord, it's like a picture. We went down to one of the classrooms and chopped it out.
Okay, good.
It's just a use case diagram.
Okay.
Yeah, the whole first day was just
Planning.
and talking.
Yeah.
Now, is this something you guys have learned through experience, or did it just seem like a good idea, or have you been told to do that?
I think it's kind of a mix of everything.
Spend a lot of time planning up front.
I mean, CS 321 here and CS 499 are both semester-long team projects, and the first portion of that is always like learning how to make a diagram like that and like actually planning out your project. So it's been taught, and then it also, I know specifically for me, if I have no clue how things are supposed to be connected, I probably can't connect them. So I need to draw it out and see like how I expect them to be connected, and then once I get into the implementation, changes need to be made here or there.
I still use the things I learned in those classes in senior design, and every day, in the stuff that I do, and especially on these big projects and things and big undertakings, the planning aspect is huge. So that's good that you guys spent some time on that. Did the plans change at all once you guys got started? Did you run into any obstacles or hit any walls and say, okay, we have to rethink this?
Oh yeah, several times.
Okay. I didn't want to do a machine learning model at the beginning, but when I got more into it, I was thinking like our data is very, sparse, which sucks, and a lot of it is just all over the place. So using the random forest, you get better prediction models. So I was like, I might as well. Plus it's like really simple to just train my own model.
Plus, like with meteorology and things like that, you have to identify trends. So just trying to analyze 2 specific data points isn't very smart or very effective. So you have to be able to analyze more than just one point of data at a time.
That's all I've got.
It does work. I forgot to tell you hit the button. If you want to hit the button.
It is drought.
And that's from the current. It's a drought because there's no
moisture.
There's no rain here.
Yeah.
Oh, that's cool.
That's it, I think. That's all I got.
I think you guys did a good job. Thank you.
Okay, so we're Team Gas, and our project is called Collected Cuisines. So, yeah, meet the team.
So I'm the team lead. I'm Henry Pham. I'm a sophomore CS major, and it's my first hackathon.
I'm Gabe Vivet. I'm a sophomore electrical engineer, and this is also my first hackathon.
I'm Angie Lynn. I'm a senior computer science computer science major, and it's my first hackathon. And Sid is a junior information systems major, and it's their first hackathon. They're not here today.
Okay, so we focused on challenge number 2, which is developing a system that collects and processes and then analyzes unstructured data from sources on the internet. And the main thing we focused on was particularly threatened data, specifically recipes in cookbooks. So here we go on a bit more about that. So one of my hobbies is like just cooking foods and from different cultures and cuisines. And one issue I've ran into is I've saved bookmarks of like certain cookbooks online or of certain recipes that I enjoy and I like to go back to, but suddenly they go down. And there's websites like the Internet Archive or like open projects where people archive websites, and there's a bunch of other archivist projects. But like, for example, Internet Archive recently has had issues with their security and their servers have been down temporarily. And just having that loss of data, or temporary loss of data, or access to the data could potentially be an issue. So our focus was, how do we store these recipes all in one place in a way that's on your own machine or on your own servers rather than relying on other archivists.
So, yeah, teamwork is kind of a bit of a breakdown of what each person worked on primarily. Of course, there was a lot of jumping around, working between different things. Personally, I've mostly focused on building out the database schema as well as actually building the web scraper to pull the recipes.
Yeah, and I mainly focused on working on the backend stuff and setting up the database and hooking it up to the API, setting up a REST API so that we can access it from like whatever device on mobile, on your phone, on your tablet. And I also helped work with like the OAuth. So we did social logins instead of managing passwords and stuff on our own, which we'll discuss on a later slide. So that's something I helped work with, integrating with our database and like making sure certain tables are protected by user. And Angie worked on page UI, like the login page, which we'll see in a little bit. And Sid worked on actually drawing up like everything and laying it out. You can see like some of our Discord messages. So like, unfortunately, some of us had like conflicting time or schedules. So we all couldn't be here at the same time. So we communicated a bunch like at midnight on Discord and over a call and screen shared and sent drawings and stuff. So they helped a bunch with laying out the idea and giving us, or whoever was working on front end, good idea of like where to put components and just focus on actually coding it out.
So features, of course, user authentication, sign in with Google, Discord, OAuth 2.0. Of course, the automated recipe importing, the web scraping to store and actually save those recipes locally to your own server. Of course, we wanted the front end to be responsive and adaptive UI, mobile friendly, fully resizable windows, session persistence, save your session or save the user sessions for seamless login, and then of course user control, easily logging out, collecting recipes, that sort of usability. So our tech pancake, stack. Backend PHP, Excel, of course. Front end HTML3 and jQuery, and there's our completed front end right there.
So that's pretty much all I was familiar with prior to this project, front end wise, because the last time I've worked on a full stack web dev project was like, I don't know, 5-10 years ago. So, yeah, there we go. But of course, that's a joke. That's not our actual tech stack. So our backend, we're using Minio for self-hosted S3. So same as like AWS S3, it has the same APIs and everything, endpoints. The nice thing, again, self-hosted, which we were focusing on earlier, because we want to be able to store everything on our own local servers. And SQLite for our single file database. The reason we chose SQLite over other alternatives like MySQL or Postgres or MongoDB was mainly because it could fit in one file and be able more portable, which was the goal. Because I can quickly take this Docker container and all the files, move it from one machine, move it to another machine, have to move 2 files, and the server entire backend is up and running. Pocketbase, so that's, if you might be familiar with Firebase, Google's technology for doing like integrated like auth backend stuff, like such as storing databases and managing tables and working basically serverless, I guess. Well, server in the cloud. But the issue with that is it's a software as a service, paid service, and we wanted to avoid using any paid services, and again, self-hosted, so we want to rely on stuff that can run on our own machines. There's an alternative called Supabase that is really close to how Firebase works, and they're also a SaaS. There's a paid SaaS for them too. But the issue is, on Friday midnight, I set up the self-hosted Supabase on my home server, home lab, and I found out that the documentation was awful. So, and there were a lot of like broken features or missing features because they're mainly focused on their paid customers. They're not, like they do tailor to the open source community by providing this, but it's kind of like everyone's on their own. The source code is the best documentation. So I migrated like a couple hours later, I switched over to Pocketbase, which is similar to Supabase, but instead of being based on Postgres SQL, it's based on SQLite and single file backend that can be expanded using Go or JS hooks. So it's really nice to work with, really good for like these kind of weekend projects, quick concepts, because even though there's issues with like SQLite being like blocking when there's a bunch of concurrent reads and everything, the nice thing is we're working with like very few users, so it's not like that big of a bottleneck. Whereas like if we were to scale up, we would want to migrate. Nginx we're using for our web host, hosting our React framework and website and all that. Traffic reverse proxy to send out between Supabase or Nginx. Docker for containerizing everything. We have a Docker compose, so it's like one command, Docker compose up fd, and we're up and running. Front end, we're using React.js and Tailwind CSS for the styling, Vite for the build system, and we're using component libraries so that we don't have to reinvent the wheel and create new pop-ups and nav bars from scratch.
So this is just a little showing of the actual OAuth 2 login using Google. It's a little on the slow end because of some of that blocking stuff involving Pocketbase and SQLite, but it just shows.
And I worked on this page, the front end, and then Henry worked on the back end.
You know, it's responsive. You can see the changing of the layout to fit. Anyway, keep going. Interactive, obviously. You know, you can pull up your recipes. Just a nice, convenient menu. Fully interactive. And then
Mobile support too, since it's responsive. I mean, it's still a web app, but we can just bundle it using the plenty of like 1,000 of frameworks for just bundling a web browser, kind of like Electron for PC, but for mobile.
So this is kind of what you don't see. This is more back end, like, wow, you really can't see that actually. So over here, you know, it's supposed to be a diagram kind of showing the way we laid out our database.
These are like our three tables
like
and showing
the way we stored data and what kind of items we were
basically all the
storing in
field
each.
types and everything.
Yeah, and then up here, just kind of going through the dashboard we had for our Pocketbase, and then this is visualized out some of the data that was pulled when web scraping, just kind of showing that out.
And having a dashboard like that was really nice for this project because we were able to quickly go in and figure out what was happening in the database without just running SQL queries via command line.
Okay, it's time to
So I already have it pulled up here. Now, in terms of website scraping, due to time limits, we mainly focused on just scraping one website well. So I actually scraped food.com, and really, you can. I mean, if anyone has a suggestion on what recipe they want
What are
from
you
you.
craving right now?
Yeah, I mean, I only have pork chop recipes. Chicken parm. Okay.
Some chicken parm.
Huh. Oh.
I haven't eaten it
Uh-oh.
today, so I'll
Here, you want to type that?
Yeah. I like the weight loss ad at the top.
Yeah.
Balance it out.
Yeah.
Quick chicken parmesan.
Yeah. Quick chicken parm. Okay, so pretty much, you just copy.
Just copy the link.
Yep, just copy the link. Click up here, collect recipe. There you go.
There you go.
Yep, it's all there. You could look through, compare it, it's the exact same, but
And the nice
locally.
thing is, because of how it's set up in the back end, it's just taking the URL and it's feeding it into our web scraper. We've abstracted the web scraper, even though we didn't support other websites. Food.com, for example, has a JSON file that they dynamically generate their website from. That's loaded into the HTML DOM in a head tag. And the nice thing is, there's a bunch of websites, like Gabe found a couple of other websites that have basically the same JSON format. Because all these cookbook websites, even though they might have different names and logos, they're pretty much owned by the same corporations and media companies. So the nice thing is, even though currently it only supports food.com, it'd honestly take less than 5 minutes to be up and running with another one, because simply we have a dictionary which compares the URL domain to one of the lists that we have and matches it to a scraper. So it's all abstracted out, so it just is able to interchangeably switch between different web scrapers. pulling it out whatever fields that we need.
So you're saying that it could match with a web scraper that'll bypass all the stupid biography that you have to go
Yes.
through,
No,
blogs
wait.
and stuff like that.
We didn't talk about that, but that was like one of the main reasons I wanted to do that. Is it's so annoying to like
Yeah.
5 pair like essays
Like
about
I
their
don't,
whole life story.
I don't care
Yeah.
the name of each chicken that the eggs came from and stuff like that.
Exactly.
So you're saying that it could.
That's what it does. It takes apart all the story. Even though it does share part of the description for the food item.
Yeah,
at the
but
top, if you go
just a
back,
small.
click on it,
Yeah, just the
Click
small
on,
description. Right up
you can see
here.
the description up top, but right after, it's all
Yeah.
the ingredients and
Yeah,
you're ready to
it's
go with the steps and instructions.
Mhm.
So it just pulls from the JSON and just
Yeah.
slaps it in there. So
And some of the elements we were pulling using like XPath, like it's scraping the HTML
Mm-hmm.
and then using XPath to grab like certain tags or like certain class names to figure out where like the author's name is or
Yeah.
the serving counts. Not everything is displayed here, but there's a bunch of stuff that's stored in the database, like including serving counts, probably like estimated meal prep time,
Yeah.
estimated calories, all of this information that can easily be displayed. It's just adding another
Parameter.
quick field. Yeah. Okay, so the things we learned. So I say sleep is overrated because I got 1.5 hours of sleep today.
Oh, goodness.
I woke up at, I went to sleep at 10:30, woke up at 12 midnight because we didn't get too much progress done yesterday while we were here because I was working on, well, I had this Pocket Base set up at my house on my home lab, but I was working from here remotely and I have it set up so that I can VPN into my home network through WireGuard. But the issue is my internet went out while I was here. And I spent 30 minutes trying to figure out why my network requests no longer were working. So I thought it was maybe like some parameters I changed, maybe like some headers I changed, or missing like user agent or whatever. And it turns out I called home, my roommate was home, checked, internet was out. So we had to run home and actually work locally because I had it self-hosted. That's the nice thing about having everything self-hosted actually, is I don't have to rely on everything if I'm already there. But once it was all backing up, we were able to work on it. The reason I wasn't working locally with Pocket Base on my device, even though it's really easy to set up one command, setting up the Docker file, is because I'm running on a M2 MacBook Air, which doesn't have any fans or anything, and I don't have the computing power. So I had to rely on using an external server, and it made it hard, even though, I mean, I'm 30 minutes from my house. The internet being off doesn't help. So that's one of the biggest things we learned is working on remote systems and stuff isn't exactly fun. And documentation for Pocket Base is awful. So we were talking about like whether we should use Firebase, Superbase, Pocket Base, and the issue is I gave reasons why we picked Pocket Base earlier because of its simplicity, but documentation was first. And we went into it knowing that. I mentioned to Gabe literally as I was setting it up on Friday before we came in and programmed on Saturday that there's almost no documentation, or the documentation is really outdated because it's currently in alpha. They're constantly breaking changes to their APIs and everything, and their SDK has no documentation. So basically, we're relying on other GitHub projects and other public projects, open source, which is again why this is really nice that we're open sourcing everything. Is the main issue was we had to rely on other people's prior work to understand how it works, or just literally looking at the source code instead of looking at the docs that are non-existent. I also learned that I never want to become a funder.
So yeah, I guess kind of what I learned personally, always another JS framework to learn. Just, there's never enough. Of course, this time we use React. I'd never touched React. Really, I'd only ever used like just pure JS for just some small things. So I wasn't too familiar with any of it. I used a few other libraries when actually doing the scraping. I think I used Axios and Cheerio to pull the HTTP request, or to do the HTTP. Cheerio for extracting the HTML elements. I guess second thing I learned is, Rome wasn't built in a day or weekend. I think one thing we did in this project is we focused a lot on building a base, like you kind of already talked about with the way we set up the web scraper to be fairly easily expandable to other things. We spent a lot of time ensuring that we had a good foundation. Like with the schema, like we didn't start any actual developing until we had that schema of all the data we were trying to save and scrape from the websites fully laid out, so we wouldn't be going back and constantly doing
Working
like
on
breaking.
migrations, SQL migrations and
Yeah,
stuff.
that kind of
'Cause
stuff.
It was a weekend project, we don't wanna be working on that overhead.
Yeah,
And another thing is, like with the expandability, the point that Gabe just mentioned, is, like for example, how we grab the links. You could easily make a Chrome extension that just like automatically saves it every time you go to a website. Or you could easily add a share button on your mobile device. Like you might have seen like, let's say you have Facebook or Messenger or whatever. On your phone, you click the share button and it says like send to Messenger and it pops it open. You can do that with this app easily. Because it's simply just one API request to our backend.
So prior to this, I had no like experience with front-end development, and so I learned some front-end development. I coded with the React, JS, and CSS, and then Sid learned that they really liked doing the front end. Like they helped me, like because they knew like some HTML and stuff, and they really learned that they like to do like the UI design and stuff, and they had never used GitHub prior.
What new text did you learn?
So personally, I learned React because I've always wanted to work with React. I was looking at React Native recently to work on a mobile app for a local business, and which is another reason why I wanted to do a full stack project today, or like for this weekend, so that I could get a bit more experience understanding how I want to approach that. And so I learned React. I learned like using like Tailwind and all those services. First time using Pocket Base as well. I've never used Supabase or Firebase alternatives. I've worked with databases in the back end, like just straight like Postgres or MongoDB, Redis, and all those like memory caching stuff. But I've never worked with like an all-in-one solution. Let me see. I think that's about it.
Okay.
So you're using a lot of different tools. Were there any like major roadblocks with some of those tools, or you had like you wanted to try one, but then end up just it wasn't working, so you had to switch
like,
it out?
For example, like the Supabase we mentioned, I literally had the Docker Compose set up after a couple hours. It was up and running, but I literally decided once I opened up the dashboard, I was like, it's a mess. There's like 15 different microservices that are part of Supabase that all need to be exposed to a different port and whatnot. And I mean, I have a reverse proxy set up on my home lab that can be connected to through a VPS that's like exposed to the public. So like earlier, that's hosted on my home server. That's not running local. So like if I open my phone up, I can see the same recipes that are on there. Yeah, assuming it's the same. But that was the main thing. Any other questions?
You guys did a good job.
Yeah, it was good.
Thank you.
Is you're pulling this out like resting on your computer?
I just want to pull away from this stuff I get into. No. Give time more subject background. Make sure the person projects and stuff, yeah. Dude.
We have one of the judges out right now.
Where's your phone? Is that okay? Yes. Thank you.
There's water in there too. They go up to water.
Yeah.
everyone. Hopefully you all have been well. My name is Kevin Goska. I'm a freshman here at UAH and I'm majoring in cybersecurity engineering.
My name is Noah Tiffany and I'm a freshman and majoring in cybersecurity engineering.
My name is Amari. I'm a freshman. I'm majoring in physics.
And we brought you here today to bring out this project called Fishing for Love. Our topic is based on cybersecurity. I love cybersecurity, so I guess one of the best ways we can do this is that we wanted to implement a way to teach basic concepts of what we wanted, and what we decided to do was fishing. I think people easily fall for an easy bait of fishing, and if you don't know what fishing is when usually somebody would email you to something that could be relatable to you. Maybe you need to pay a car payment, or one of your family members just emailed you saying, hey, I need some money, and usually they would have a link or something. And obviously, if you don't check for those links and see if they're not suspicious enough, you would click through it. And what we wanted to do was make it in a way to teach you how to do that, and that is where Fishing for You comes from. So, from there, again, like I said, we wanted to implement it in a really nice and unique way. So what we did was we made sprites of fish, and we wanted to keep it in a really nice tone of having a joyful, cheerful way so that you can understand what fishing works and what to avoid. Because there's obviously many errors in phishing emails, and there's some obvious to the point in your head you're like, this is too real, or just too good to be true. And we wanted to implement that in a way. And here's our beautiful thing. I worked on the front end while Noah worked on the back end with our other partner, Caitlin Lynn, who is apparently not here due to time management and stuff. If you can go on to the next slide, my apologies. And go on.
So basically, we knew it was a phishing email based off like, the provider, the domain, if it's like some Gmail address trying to act as if they're like some school administrator, the usual stuff. If it's like the domain like from UAH.edu, that's more, trustworthy. You look for that kind of stuff, and that's kind of, impersonation, that type of stuff. That's what we cover. And this is also, we did some like kind of background research to kind of assure us of our, like how correct we were when we were creating the email addresses. So basically, this is some extra information. This is the website that we used. We had to cite it, just reference. And there's a live demo. Well, we have a video I can do. 1 minute. Kind of showcases like, okay, so there's the email address. It shows the description behind it. The description is supposed to be the actual like prompt sent through the email address. You say, you swipe left if you decline it. It's like, hey, that's scam. Don't click on it. But if it's, if you trust it, you swipe right, or well, in this case, you press the right button, and yeah, it's kind of like you match. Maybe eventually, if we kind of, if we had a little bit more time, we could have included maybe like after you match, you could have like some kind of interactive service where it's like you match with them and then you get to like kind of like communicate. I guess something like that. That would be pretty interesting.
Yeah, I think one of the things that we should have improved overall was the planning. I guess it just felt more of a rush concept of what we wanted to do in fishing. I guess in the meantime, if we had more time, we could have introduced something into there and probably find a way, like let's say like you like it and it turns out to be a phishing email, we could include an error into it and explain why it's a phishing email and show you the next time how to not fall for it. And I guess beforehand we could have, do like a little startup thing before you start playing to explain what phishing is and the context to it and include many other objects and stuff. But I guess that is the thing, time kind of made us really snappy and just wing with it. And now we are here presenting this project, so.
In the back end, we used Flask, and I'm pretty new to, well, generally web development, so I also worked a bit with, the front end. We just did XML, some JavaScript, working with some of the interactivity between it. It's all decently new to me. I'm a freshman. Cybersecurity engineering. We're all freshmen, so yeah, it's kind of a lot of GitHub was really useful to know. Did pretty good. Learned a little bit about that, a little bit more than I did before. So I think I took away some valuable things. Any questions, anybody?
Amari, as a physics major, how did you get involved in this?
Yeah, that's a long story. I'm taking a minor in computer science, and I kind of do that as a hobby, and so I joined this club, and they're having this hackathon, so I decided to come down here. I thought it was going to be like a maybe an hour or two sesh, but I got immediately sucked into this group, and
Welcome
I'm
to
here.
computer science.
Yeah, and he made some of the spreads as well, so he did help out. He helped out with the slideshow. Well, he was the main contributor to the slideshow, and I appreciate that.
So what are some of the challenges you guys ran into?
I guess that's one of the best starts with was preparation. We all thrown out ideas of what we truly wanted, but then those ideas just clash with another, and we have to make something work in that certain amount of time. And when we did find what we wanted to do, I guess that is where you start preparing to find tools and to find certain softwares or something that you want to do to learn. And it felt like more of a rush, so we just kept going and going and going. And I guess that is one of the best ways to start before you do a project, is to plan it out, so you're not rushing the project and it doesn't look unfinished.
You're all hearing a common theme, right?
Yeah.
You all experienced that. Did you guys have this moment where you were going, we can't do all of this that we want to do in this amount of time?
Yeah, it was more like a procrastination of, we're gonna reach this, but right now we're at this, and we should be right here.
Right.
But without that planning and all that.
Yeah, scope.
Big a mess.
When you guys plan, scope is one of the most important things, especially for these, these hackathons, these weekend sessions, stuff like that. And the more hackathons you do, the more you'll experience that. And it's good that you guys are learning this stuff early on, and you're all freshmen on this team. And I guarantee you that you guys are going to call back to some of the experiences that you've learned just through this hackathon and be like, yep, there's that again.
I'm sorry for my
No,
interrupting
please.
you, but when it comes down to scope, I do get it. It's like at the start, we did think of like some other idea that was like some storyline. I was like excited about it, and just like like a potential like future game I was thinking about making, but it wasn't quite like, okay, so our scope's the weekend. I cannot make some storyline. I can't do all of this. I need to come up with something else. And it took some time like alone to just like think about like, hey, what could I really make in this time frame with our set of skills? I'm not too familiar with HTML. Oh, I've dabbled in JavaScript. I've done quite a bit of Python. Like I've experienced in Python. That's kind of what I knew. So Flask, I was like, okay, let's do some, do what we can do.
Okay. And that's how you decided on Flask?
Yes.
Was it you touched on it a little bit before?
Tiny bit, not too much, but I've heard about it.
I think that's all I got. You guys did good.
Yeah, thank you.
Thank you. Need something like that for my mom. Or some of this government training.
Yeah.
I just tell my mom, don't respond to anything. If you have any questions, call me.
Sometimes we're almost on the floor at work. It's like,
Oh yeah.
It's not like running through. Oh crap! I gotta do this thing. Like you said,
That's my secret. I don't respond to any emails.
It's resolution.
No,
Yeah.
99% of the time I'm like, this is a test from security.
Yeah. That's good.
Good. Hello. I want to start off by thanking the ACM Club and the Open Research API, or the open source API, whatever was provided for the BOSS project. It's been super fun to work with. This event has been super awesome. We nicknamed our project Orion, the Observation, Reconnaissance, Intelligence, and Operations Network. Credit to ChatGPT for that name. It's gonna go to the next slide. So, I'm Isaiah. Unfortunately, not all of our teammates could be here, but I'm Isaiah. I'm a full-time data scientist and machine learning engineer at Tritium Corporation, and I'm also a graduate student. Aiden is a full-stack developer. He's actually still in high school, only 16, but contributed like the most to this project. Unbelievably impressive. Jacob is not here. He has some modeling and sim experience from his internship. He's a senior. And Caden is our general skills software engineer, and he's a freshman. Go to the next slide. So The reason we chose this problem set is I have a lot of data science experience. I was excited to get something to do with data. Aiden is super great with all the front end visualization stuff, so we knew that was going to go well. And Jacob also has experience with modeling, from his internship actually modeling like planes, UAVs, satellites especially. So we thought this was going to be perfect for us. Good next slide. So the overview of what our project tries to solve is we take in real-time and historical data. So we have more than one API that we use. And then we also process the information and we hope to provide insights. So the whole goal ultimately is we want to take in and analyze weather data to determine what kind of implications they could have for systems in the area. So whether they're UAVs, boats, we never got around to airplanes with ADS-B, but we would really like to in the future. There's a ton of applications for this: public safety, security, environment, defense especially. Some of our tech highlights is, I really hate that this never made it in because I put a ton of work into it. We had a machine learning element to this that was pretty close. I'll talk more about that in just a second. We do have multi-source data, like I was saying. So we have our weather radar stuff is real time. That's actually coming in with like a 2-hour history. We don't do any calculation on moving forward. It's insane how quickly a weekend goes by. And the coolest thing about this project, in my opinion, is that it's completely portable. So like another project in here, we also use Docker Compose in a home lab to host some of our stuff. So that was pretty cool to see. But we containerized the web server, the GUI, and we also at one point had a Postgres database that we ultimately moved away from that was also containerized. Okay, next slide. So for the machine learning side, this problem is actually really hard to solve. We found a paper that was published very recently from some people at NVIDIA, MIT, specifically LinkedIn Labs, and the purpose of this stuff is to take in Nextcloud Level 2 data and predict the likelihood of a tornado in that region. So I've never worked with NetCDF files before, so that was a huge learning experience for me. I have worked with severe class imbalance, and that was very familiar and a huge problem with this. We were not able to finish the data pipeline on the actual production side. Really unfortunate. Shaping the data was really difficult. It was very late last night. So we had huge goals. In the paper, their models have very bad false positive scores, and I was pretty confident that I was actually going to be able to fix that with some synthetic data, stuff like smoke, or maybe using a XGBoost model rather than like a custom CNN like they were using. They had some success with random forest, but I really think that the results can be improved. The most important contribution of this paper was not necessarily the models, but more so the data set. As far as I'm aware, this is the only open source data set for tornado likelihood based off the Nextcloud Level 2 data. But we were able to recreate the paper results. I was able to run some of their pre-trained models and get some results. Like I said, false positives were great, but we'll leave it. Go next slide. So this is what the weather data looks like. Those NetCDF files are pretty complex, but also very cool. So they are binary data that store information in multidimensional arrays. So yeah, like this is not exactly correct because you have things like latitude and longitude. You have things like reflection and more meteorologist terms that I'm not really familiar with. These are the different variables that the model learns and plotted in a human readable format. They just get like the raw data in a high dimensional format. Yeah, so for the GUI though, we don't actually display this Nextcloud Level 2 data or these NetCDF files. That's a different format, and that is literally just going to be precipitations. So we can move on from this. I don't want to take up too much time, but this kind of highlights the severe class imbalance. So of your samples, you have the majority are not even tornadoes. The second highest population is warnings, so still not really tornadoes. And then of the confirmed tornadoes that you do have, which is only like less than 7%, they're far and few between like low severities. I mean, you only have 172 samples of like upwards of 120,000 for EF4 or 5, which is just not enough, to be honest. Let's go to the next one. This is just another zoomed in slide. I didn't know we were going to keep projecting, so we can skip this slide as well. So for the UAV and AIS data, which is like ships, unfortunately Jacob is not here, and he did by far the most work on this. I wish I could speak to it a little bit more, but I'm not really going to try. We do have abilities to track the main enemy, but you can kind of see what all we're tracking, what all we're getting when we do the demonstration in just a second. Go to the next one. So our tech stack is pretty cool. Aiden handled the entire front end. He's using SvelteKit, Tailwind, the Rainviewer API, and the Over ScissorHub API, which is amazing. And on the back end, we're using PyTorch and Keras, which is the data set they produce is called Tornet, and they try to be like very fluid with their backends. I wasn't super impressed, but So we had to use Keras. I am a PyTorch through and through. We use Fast API for serving our stuff. Like I said earlier, we use Docker and Python. Go next slide. So we're gonna jump into the demo. There's a QR code. We technically have mobile support. It's not like the main selling point. You can refresh the page when you open it up, and it should work okay. You can also navigate to orion.harville.dev if you know how to spell all that. But for now, let's go and navigate to the page. All right, so you maximize the window. Okay, so here we are. This is pretty cool. We are getting these are next rad stations. These are actually like what radars. This is radars that are getting this data. So these are real. You can toggle them on and off by clicking the show radar stations at the top if you want to clean up your map a little bit. You can turn it back on. You can toggle off the weather radar as a whole, and that goes away, and you can turn it back on. So this is just the radar tab. We can also show the UAV tab if you click to the left. So here's our UAV. If you zoom in really far, Caden, that would be great. Just keep going into the UAV. The UAV is actually really cool. I've been super happy with Jacob. So the Open Sensor Hub, this is the real-time simulation. That's actually like the UAV is actually moving, and we are tracking how it moves. So that's what these points are. So it started back here. It's moved this way. We have our pitch and our roll. We actually, at one point, it never made it into main. I want to say really quick, our GitHub practice was we make an issue, like a feature or a bug. We open a branch based on that issue, and we merge it into main, and it worked out super well for us. So the drone just moved. We got a refresh from the API. If you zoom out just a little bit, you can see it again. So these are the metrics we're tracking. At one point, we had a way to see what the camera FOV was of the drone. It never made it into main. I'm not exactly sure why, but it was a cool feature that's unfortunately not here. If you click the drop down that says neutral, Caden, you can change its combat status to friendly or enemy, which is kind of like a more defense feature. It will update after a while, but either way. So yeah, that's the drone information. If you want to go ahead and click AIS, and you zoom out here, you can see all the ships in the area. So we have a lot along the coast here. There's a couple of lakes. Would you do me a favor and toggle off the radar stations just so it's a little bit clearer? You can also click on these ships and get some information about those. So that's the speed, the heading, its positional information, latitude, longitude, and then the MMSI ID. Right here we have where your latitude and longitude is with the cursor, which is super neat. On the left side, you have a typing box where you can actually navigate to coordinates. If you want to go ahead and type in some coordinates, then we can go there. So some of you guys may recognize this address as the Breaking Bad house. We have a date up in the top, and we also have different map styles. So if you want to go back to the radar page, Caden, we can zoom out again. Also, there's one more feature I want to bring up. The timeline is scrubbable and autoplays of the last 2 hours. And we can also draw on the map. So if you click this, you can pretend to be a meteorologist and draw things. So pretty neat. Let's go ahead and change the map styles. So we also have like oceans. You can actually see like the underwater topography of the ocean. We have satellite image, which is probably the coolest, honestly. And we have like a street view, which is interesting, I suppose. But yeah, so we try to be super modular and address a bunch of different use cases, but specifically weather tracking with the hope to provide analysis for systems in the area. If we had more time, we would love to include ADSB in our own API that allows integration with our service, but time constraints were insane. So yeah, are there any questions about this?
Who do you see as the users when you were?
So I think that this has a lot of applications in defense for sure, but I also think that I think this could be useful for national parks or anything that wildlife preservation, anything like that, or even just hobbyists who want to see like their drones that they have in the area. ADSB there is a standard for ADSB. I've had the displeasure of writing an ADSB modulator and demodulator. It's ridiculous. But yeah, so I think that it's really anyone who has systems that can be registered with our application, which is super broad, but yeah.
Did you say you're in the industry right now?
That's correct.
Correct, and a grad student as well?
That's correct.
And it was data science stuff?
That's correct.
So I assume that as a function at least of school, you've worked with weather data before?
I have not. This is my first time. My specialty, if I'm allowed to have a specialty, is in radio frequency and RF, with a specific focus on adversarial machine learning techniques to cognitive radars.
Okay.
So this is not familiar to me. I know nothing about weather data until now, and especially this file format. The NetCDF standard changed to H5 files, or a base on H5 file, which I am familiar with. So that was helpful, but this was very unfamiliar and part of the issue with getting this like integrated in the front end.
Did any of you have experience with weather stuff? Working with weather data at all? No. Okay. And then part of the decision, as far as your tech stack, came from the people who wrote the paper, right, to recreate that?
Not exactly. The decision for the tech stack on the front end was Aiden's personal preference. Far and few, I mean, like, wealth of knowledge in the front end domain. We did not have enough experience to argue, so it's whatever he's comfortable with, whatever helps him work the fastest. Python for me, I knew I was going to take on a lot of the backend responsibilities as well. We knew Python could be super fast. We knew we were already going to have to use it for the machine learning stuff, so we thought, let's just throw out fast API in Python, super quick and easy. Good enough for this. A lot of the stuff on here is we don't have to store a lot of this data, so it's really just API calls. So we're not super database heavy. Really, like the main thing we're serving from our endpoint is radar positions.
Right.
And then the Docker choice was personal preference and previous experience.
Okay. What were some of your biggest takeaways?
Biggest takeaways is class imbalance, and I honestly, I'm not
more zoomed out.
More zoomed out. Okay, let's see. I'm not completely convinced that weather analysis can be done with just the features you get from X-ray data. I think you need more information, especially in the sense that we don't have a lot of data from like the archives on tornadoes. I also wish that I wish we had had more of a direction going forward. So to be completely honest, when we started out, we did not know about the open source API or I know I'm saying it wrong, the Open Sensor Hub API. So we had to kind of reverse engineer that back in. And I also, this is my fault, I also failed to realize how light we were going to be on the database side.
Right.
I spent like the entire first night, well, not really the entire first night, but I spent a good amount of time on the first night setting containerizing Postgres. And we were going to use a Postgres DB to serve everything. We were going to share data between that the model was inferencing on and this, even though it's not strictly necessary. That's what our goal was. So I know that Aiden had some pretty severe issues trying to display Next-Red data on here. There were some libraries with like 30 GitHub stars, which is a little concerning. So really, I think time to do a literature review and view other open source projects would have been really great for this.
Right.
100%. Anything else?
That's all I got.
Awesome.
That's good stuff. Thank you.